Hello, today I will be doing the second SortCL video. In the last video, we ended up going over a PowerPoint, just showing you a very basic few examples and essentially the breakdown of how the script looks. Today, what we're going to do is I'm going to go into a little bit more detail about what those mean, and then we will be given a few real-world examples. But I have also intentionally made some of the scripts break to show you what it looks like when the scripts don't do exactly what they're supposed to do. So before we get started, let's go ahead and take a look at just some basics again. So just as recap, if you can recall, we have an in file section, a job section, and then an out file section. So let's go ahead and start with the in file. Again, it specifies the source, and I do want to go ahead and note that if it is in red, that means it is required for the script to work. It has to be in there. There are no exceptions. So we have a /in file. It's going to take the source of what we're looking for, and it's going to do some sort of process. And as you can see here, I actually have a few of these spelled out for us. So random is going to be row gen or a generation. So essentially creating data from scratch. ODBC is database, record is file, so on and so forth. And I'm not going to go into everything that we support, but instead the most popular things that we do use on a day-to-day basis and items that I think are going to help you the most. If you do need specific examples for more complex logic or things that we do support that I haven't covered here, I'll go ahead and leave a link to the manual in the description for you to take a look at. I will also, when we get to the workbench, I'll show you how to access the manual straight from there as well. All right, and then we have this alias, and again, it's just a name that we use as a reference to that source or target. Then we have this /in_collect, and this is actually going to be the layout of how it looks. So it would say /in_file, and then the next line would be /alias, and then if we wanted to add this in_collect, it would be /in_collect on the next line. And what an in_collect does is it will read only the specific amount of items. So if you have an in_collect of 10, it will only read the first 10 entries in that source. And so now we're moving on to our fields. So from there, we would do a /field, and then all items inside the parenthesis, and that's exactly how it will look. So it's /field equals, and then 2 parentheses. And then we have the field name, which can be anything. Again, it's just a reference, but something to note is that it should always be first. And then similarly, if we have like an odef equals or something along those lines, it will always be last, and I'll show you what that looks like once we get there. So we have this /field equals, and then inside of here, it would be field name like that, right? We'll do a comma, space, and then it would look like this, type equals, and then once we put the type, it would be a comma, and then so on and so forth until that ends up being complete for the field. So we'll move on to the type. So we have ASCII, numeric, whole, integer, and date. Again, these are just some common ones, whereas ASCII is definitely the most common out of all of them because it generally supports both strings and numerics. There are situations where some of the other data types are required. Then we have our positioning. So we have our position equals, and it's whatever position the field is within the source or target. So essentially, it should go into ascending order. So it should go 1, 2, 3, 4, 5, so on and so forth. Then we have the separator, and this is going to be the delimiter of the source or target specifically. And then we have this odef, cdef, etc. And this is what I was talking about, how we won't get into a very specific example here, but odef is going to be for databases, so on and so forth. We have this frame, which essentially just applies a frame around the data, and then precision is used with numerics to specify the amount of decimal places. Now we have an inrec. So an inrec is a replacement in file that does not take in any source. And I know that sounds kind of weird, but essentially it just replaces the in file without needing to specify a source because the source is already taken from the INREC. That's just the best way to think about it. So the cool part about an INREC is that you can add more fields than what was inside your in file, and you can reference those fields in your out file. So this is really cool when you're trying to concatenate strings together, or let's say you are trying to do some math or some logic on some fields that you don't want changed, and you want to keep the original, and then you want to add an extra field inside of your out file, or if you don't even want to add the field, if you just want to do some more complex business logic, an NREC is where you're more than likely going to be doing all of that. So here, I'll just show you a very quick example of what it should look like. So here we have a very simple in file with one field, our INREC, which essentially just takes this field that's right here. So essentially, all the fields you would copy and paste directly from your in file to your INREC. And then you have your job and then your out file. But like I said, the cool part is that here you would potentially be able to add a whole nother field. So you could essentially just make an entire new field and have it with whatever information you want. But again, something to note is that that field is going to be blank, right? So let's say, for instance, we had two fields. We had field 1 and field 2 here. And we were trying to find the total of both of those fields. We could use an INREC to then create a field 3, which essentially will just say field 1 plus field 2 will equal to field 3. And then we would just take those numbers from field 1 and field 2, combine them together, and we would get field 3. But for this example, even though we're not changing anything or we're not doing anything to any of these fields, this would still work as a script. So essentially the INREC again just replaces the in file. Okay, moving on to the job section. And this is again required. It could be /report, sort, key, or join. Then we have the out file, which again specifies the target. Then you have your process, your field, your alias, and then instead of an in collect, it's actually going to be /out collect. And this will allow you to declare how many fields you want to write. So if let's say you have an in collect of 10, meaning that you are only reading the first 10 entries, and you have an out collect of 5, it's only going to write the first 5 entries. So with that out of the way, we'll go ahead and take a look at some actual examples. Okay, now we're actually inside of the workbench, and as I said, if you want to get to the manual, you would essentially just go to help, you would go to CoSort, and then CoSort use your manual, and then it will bring up the manual for you. You can also do this for any other products that we have here. So before we get started, this is essentially just one very large script where I have different types of scripts commented out. And one thing to note is a quick format is going to be Control Shift and F, or you can just right click, source format, and then a mass comment is going to be Control and then a slash. So let's go ahead and take a look at this very simple example that will 100% work, or should work anyway. So we have that in file, which is taking in this simple doc.txt. And since the script right here, this basic.scl, is located in the same directory as this simple doc, we don't have to do any relative or absolute pathing. Well, I mean, this is relative pathing anyway, but because it's located in that same directory, we don't have to do anything extra. So we have our process equals record. We have a single field, and here I'll show you what that simple doc looks like. So it's essentially just a bunch of different bits of information here. And that's why it is of type ASCII. Then we have a /report, so essentially just reading and writing from source to target. That's all we're doing, source to target. Then we have this out file to this basic outfile.txt. So one thing I want to show you is I'll go ahead and just delete that basic out file. That way we don't have it in here and you can see what it looks like. So we'll just go ahead and run the script. So we will right click and then we will do a run as and then an IRI job. And then as you can see here, It says event, 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 and everything is looking good. It would say error if there was a problem here, and then 90% of the time there would be a pop-up screen that tells you that it ran into an error. So essentially, since we're not doing anything different to this infile or this field, right, we should essentially see the exact same bits of information that's inside of this simple doc to this basic out file, which we do. So it's exactly the same, which is perfect. That's exactly what we wanted to do. And this is actually a very, very common thing because sometimes for some scripts, you may need to only mask, let's say, 4 columns or 4 fields, and you'll have 50 columns in a table. So those other 46 columns are not going to have anything done with them, so you will essentially just be reading from them and writing to them. So if there's anything messed up, whenever you're doing these scripts, and some of your other data is being altered and you don't want it to be altered, it could be because of the field may have something to do with it. So you should go check that field and where that data is being messed up on. So now let's intentionally break the scripts and see what happens. So I'll just go ahead and highlight this. We'll do a control slash and it will mask comment it and then we'll uncomment this. Okay, again, we're just reading from the simple doc, doing a process of equals record, and as you can see, we're using the wrong field names. So here we have slash field equals client info for our source, our job, and then our target. Everything is exactly the same except this right here. So we have a client info and then we have a field 1. And it's okay that we named this client info. That's perfectly fine, again, because a field name is just a reference that we are using. But when we go ahead and run this, here, let me clear this log for you, just that way you can see. And I do want to point out that when you're writing to the same place over and over and over again, it will just replace the data that's there, right? But that's only for this specific example, right? So it's different with databases and other different uh, sources and files and things like that. But for this very specific example, it will just replace the data that's there. So I won't be deleting this basic out file every time for that reason. So we'll go ahead and run this and we will be hit with an error. Oh, it wants us to save it because we commented that out. Okay, so here you can see at the bottom we actually have an error. So it says basic outfile.txt.field1 source unknown. So that's very, very important to read that it's saying basic outfile.txt. So it's essentially telling us that it's the out file where the problem is. And then it's going to be field 1 where the more specific problem is. And it's saying source unknown. And it will kind of say the exact same thing here. And we'll click OK. So when we head over to the basic outfile.txt, and then we look at field 1, we can see everything looks good here. So we have to then look at why it's saying the source is unknown. And that's because it doesn't know where field 1 is. It doesn't exist. The reason is because client info exists. So we can just copy this name, paste it there, and now we're referencing the information that is inside this client info field. So let's go ahead and save that. We'll run it again, and everything worked out fine. And our out file is exactly what we were hoping for. Okay, so let's move on. Go ahead and comment that out. And we will clear this. Okay, so I'm pretty sure I already covered it, but as I said, there is relative and absolute pathing. So this is a relative path. So essentially we're going up one directory and pulling this simple doc.txt. But again, as I said, since we're inside this basic folder, that's actually where this is located. So if we try to go up one file or folder, we would be inside of this, which then does not contain that simple doc.txt. So let's go ahead and run this and see what happens. Don't forget to save it. We'll run as and an IRI job. Okay, so here you can see we have a little bit more information. So as you can see, it's doing an event. So it's attempting to run this basic.scl, and then it's immediately running into an error saying that this // simple doc.txt does not exist or no such file or directory. So anytime you see this no such file or directory, it essentially just means it is unable to find that source or target that you were specifying. And again, I already explained why that is, and that's because it's actually not inside that folder, and it's inside this folder instead, the folder that is contained within this basic right here. And then when we change that, everything should work perfect, which it does. And we'll take a look, and it's exactly what we were hoping for. So let's move on. Okay, so here we have different out file extensions. So here we're reading this simple doc.txt with a process equals record. Again, same exact fields. Then we have an out file to a basic out file.json. So this is reading from a text, writing to a JSON. And the reason it's writing to a JSON is because of this .json tag right here, right? So let's go ahead and see what happens when we run it. So as you can see, we actually don't get any errors, which allows us to do that. Then when we open it, you can see here that everything looks exactly the same, exactly what we wanted. But the difference is that it's now inside of a JSON file. But as you can see, it doesn't have the actual JSON format, and that's because we only changed the extension of the tag of the file that we are writing to. So it's not going to sit there and create all of these, the JSON information that we need in order for it to have the format of JSON, but instead it just writes to a JSON file. So we'll go ahead and delete that and move on from there. We'll comment that, and then we will uncomment this. So here we are intentionally doing the wrong positions. And this one is a little bit harder to see a lot of times. But we do have a quick way to fix it. So you just right click IRI, and then you have reorder fields right here. And then this will sort the fields to the correct ordered positions. So we'll go ahead and run this. So we'll right click, run as, IRI job, and we will save it. And it will actually let us do the job, right? But when we take a look at the out file, you can see that there's actually nothing inside of here. And that's because this field position 2, when we go back to our simple doc, there is nothing here in field 2, right? There's no data. We only have one column or one field. So it's referencing data that doesn't exist, and that's why it looks like that, right? There's nothing there. And then let's say, for instance, while we're here, we change this to position 1, and then this stays at position 2. We'll go ahead and see what happens. Then we'll look at the basic out file. All right, as you can see, it looks similar, but it's not exactly what we were looking for. And that's because since we are tab separated, right, that's our delimiter, we have nothing, we have empty, and then a tab, and then our field information. And the reason this works, right, is because this in file is referencing the information inside of this in file document. So that field 1 right here contains all of this information, right, in this column. This out file, this basic out file, it doesn't care where it's writing to because it already has that information inside of field 1. It has that data. But it's just telling it to write it to position 2 inside the out file. And that's why position 1 has nothing, or field 1, column 1, whatever you want to consider it. But then column 2 has all the information. All right, so we will continue to move on. All right, and now we have a different type. So I will bring up this simple doc. We were using ASCII this entire time, so now we have a type of numeric for both the in file and out file. And as you can imagine, we don't have only numerics in here. So let's just go ahead and see what happens when we do the wrong or a different type than what's expected. We'll do run as IRI job, and again, no errors. We will open up this basic out file. As you can see, we now have zeros where all of the data is that doesn't contain numerics. And even this $4.23, as you can see, it just can't handle that. We do have a money type, which can handle that, but for this numeric specifically, it cannot. Same thing with all of the other bits of information, right? As you can see here, it actually added a .00 to everything, and that's because the precision on a numeric type is going to be immediately declared as 2. Right, so let's go ahead and I'll do this on the fly real quick. So we'll do precision equals 0. Also, one thing to note is that it's all done in uppercase, but it doesn't have to be. You can do it in lowercase. So we'll just copy this and then we'll paste it down here. We'll save it. We'll run as. And then as you can see, everything went fine. We'll go to this out file, and now we do not have any decimal places at all because we set the precision to 0. And this works for the numeric specifically, right? So let's continue along. All right. I was just taking a look at the time. So here we have the changing the action or the job. So here we have a process equals JSON instead of a process equals record, but we are keeping the .txt tags. So let's go ahead and see what happens. We'll save it. We'll run as IRI job. All right, and as you can see here, we are actually hit with a error saying the JSON parse header information is missing in the input file. And that would make sense because we are reading from a text file and not a JSON file. So it would be missing that bit of information. But let's say we change the out file to a JSON. Does that change anything? It does not. And the reason is because it's looking for that information inside the input file, right? Now, let's say what happens technically if we want to just say that this is a JSON file instead of a text file. Will that work? It will not work because then we are hit with the other error saying that this simple doc.json does not exist. There's no such file or directory. And that's because it's looking for a .json simple doc, whereas it doesn't exist. We have a simple doc.txt. So you can't just force it to do something it doesn't want to do. All right, we will move on. And here we are now moving into a multi-column file. Essentially, we're just putting everything that we learned all together so that way we're moving into a more realistic approach. For the most part, the information you're trying to read and write to isn't only going to have one field or column in it, and instead it will always contain multiple. So this is the multi-column input. So let's take a look at that. We'll get rid of this simple doc, we'll get rid of this basic out file, and we will open up this multi-column input. So as you can see, we have a name with some numbers. A name, some numbers, name numbers, so on and so forth. So let's go ahead and see what happens. And just to recap, we have a field that I'm calling names. It has a type of ASCII, a position of 1 with a tab separator. As you can see here, this is in fact tab separated, right? So that's also very important to note that now since we're in multi-column handling, we need to make sure that this delimiter matches the delimiter of what it was before. Whereas if we had this single file with this one column, the separator doesn't necessarily matter that much because there's no column to reference that separator or delimiter to. But since we do have multiple columns, we need to make sure that that separator is in fact what it is supposed to be. Then after this names, we have this numbers, which is going to be of type ASCII, which is fine, position 2, and then separator tab. And again, we have a process equals record, a report, essentially again, just reading and writing. So let's go ahead and run it. And we ran into no errors, which is perfect. And again, I want to point out here that we are using um, this form of infile of gathering this file instead of just using it straight from this basic folder. I intentionally have it outside of it so that way you can see what the relative pathing looks like. So we'll open up the basic out file, and as you can see here, we have Mike 1, 2, 3, 4, but that doesn't really look right, does it? And the reason is because this actually has some decimals with it. So that is one drawback of ASCII, is that it doesn't handle decimal places. But everything else looks exactly the same as it should, and even this Mike looks as it should. It's just missing, though, that decimal place. So moving on, we'll go ahead and comment this out. And then for our last example, we're going to have the field layout being disorganized. So essentially what that means is we just have the names. And the reason, again, that this works is I just want to point out is that this field names is referencing the in file field position 1, and then this out file field 1 is referencing names with the information, and that's why it's just reading and writing. Okay, we have a names with a position 1. Normally we have type first, type ASCII, and then separator. And then each one of these are just going to be different just for you to see the different ways that it looks. But we'll go ahead and run it. We'll save it. And as you can see, we don't hit any errors. And the out file is going to be exactly the same. And the reason that this has this .23 here now is I don't know if you caught it, but it's going to be because this right here, this hole. I actually forgot that I put that in there, and that's because this numbers right here, this hole actually doesn't support decimal places, whereas ASCII does, right? But in this type down here, ASCII does support decimals, right? So that was a mistake on my behalf. I got a little mixed up there, but so hole does not support decimals, whereas ASCII does. And so the reading and writing looked perfectly fine. Everything looked great. Now, something I kind of want to do on the fly just to show you now that I'm thinking about it is let's say, for instance, we are referencing this bit of information here in this in file. But let's say that we want to switch the data around, right? So instead of names being here, what if we had numbers first and placed it here and set names there? So theoretically, this should work because we have this numbers, which carries information, then we have this names, which carries information. We're essentially just reorganizing the way that they look, right? So we'll go ahead and save that, and we will run as an IRI job, and we get no errors, and we will look at the out file, and everything is actually switched, which is exactly what we were hoping for and expecting. So if any of the format or any of the data needs to be reformatted or changed column positions, that is one way to do it. Essentially because, again, this is just solidifying, and this is very important because this does cause some confusion, is that since we are declaring the information where it's stored, essentially just think of it as a variable. So this names has the information inside of column 1 since we're declaring it as position 1. Then this numbers holds that information in column 2. And then when we're writing to the out file, it doesn't matter or care that this was the order before. We have the information we need inside these variables, which is going to be numbers and names, and then we can place them however we want inside the out file. And with that, that was just a more in-depth look at the SortCL scripting language. And again, these are very basic examples. These have no field level functions or any bit of logic to them. Essentially, they were just very simple read and writes, But I hope to covered a lot of the errors that you would normally see when you're trying to perform scripts, and hopefully it helps you out. Thank you for watching.